Greetings, this is Mr. Garwood with our continuing video series on Calculus, second edition by Briggs, Cochran, and Gillette. This is a continuation of our lessons in section 3.8 on implicit differentiation. And my goal for this video is for me to work 2 implicit differentiation examples and show you the process for finding dy dx. So I have a relationship on the plane, which means that I should be able to find a slope of a tangent line anywhere on this value. This example is actually the one that's given at the very start of this section of our chapter. Now, so what I'm going to do is I'm going to start here by applying the derivative with respect to x operator on both sides of the equation. This is kind of like back when you were taught if I add the same thing to the both sides of an equation that it's the same. Well, if I take the derivative with respect to x of both sides, I should still have equality maintained. And as we noted before, when I take the derivative and I'm adding, I can simply just break it up into pieces. So I have the derivative with respect to x of x plus the derivative with respect to x of y cubed. I'm going to go ahead and make this minus the derivative with respect to x of x times y equals the derivative with respect to x of 1. Now, derivative of x with respect to x, that one's nice and easy at least. That one's 1 using the power rule. The derivative with respect to x of y cubed, we kind of hinted at that in the last video. What I'm going to do is I'm going to take, so if I come over here and I say y is a function of x, so d dx of y cubed, I'm going to chain rule it and say, well, that's 3y squared times the derivative of y with respect to x. And there's my first time that dy dx is going to show up here. So 3y squared times dy dx. Now, here's where things get awful. I'm now going to subtract, and I've got 2 functions multiplied together, and I actually have to apply the product rule here. So this is going to be derivative of x, which is 1, times y, plus x times the derivative of y with respect to x following our power rule, or our product rule, and that equals 0 because the derivative with respect to x of 1 is, or of any constant is 0. So I'm going to simplify this out. So I've got 1 plus 3y squared times dy dx minus y plus, or distribute that negative, minus x times dy dx, and that equals 0. What I need to do is I need to get everything that has a dy dx on one side and then everything that doesn't on the other. So I'm going to subtract 1 and add y to both sides. So now I can say 3y squared times dy dx minus x dy dx equals y minus 1. I'm going to have to continue this on a second sheet of paper. So I'm just going to rewrite what I just said. So I said 3y squared times dy dx minus x times dy dx equals y minus 1. Now I'm going to factor out dy dx. So dy dx times 3y squared minus x equals y minus 1. Cool. This times this equals this, which means I can divide both sides by 3y squared minus x. And I have that the derivative of y with respect to x of this relationship is y minus 1 over 3y squared minus x. That's that example. It's a lot of algebra. It's a lot of the chain rule and just understanding if I differentiate y with respect to x, I have to chain rule it and remember that I've got to multiply that by dy dx. So let's go ahead and do one more in this video. On second thought, I'm actually just going to make this 2 videos. So I hope you found this video useful, and I'm just going to make 2 example videos. That way you don't have to play around with the timing. I hope you have a good day.